Ability. I want to talk about it right now.
What did you say though?
So continuous versus differentiable. Comfort differentiable. So what is a differentiable? So for me, like I draw out a diagram. What? Oh, somebody need to sign the AUP. Oh. Yeah. Eva, Matthew, and who? Amir Martin. Okay. Can they close the door in the class or no?
When you get your laptop, you're supposed to sign like an agreement. I did do it. They've been messing it up, so I'm going to have to redo it.
I'll just go there at the end. Okay, so continuous versus differentiable. So for me, I draw this. I do sometimes I train teachers how to do stuff, and this is one of the best thing I ever come up with. I think. So sometimes I train other teacher in the county. Sometimes they will ask me questions, and well, mostly it's my old school. Okay, so on the bottom, so there are 3 layers, and you cannot have the bottom layer without, you cannot have the top layer without the bottom layer. So the first layer is going to be limit exist. So limits exist. And in terms of graph, that's going to look like this. Limit does exist at this situation because it has a hole. Also limits as x approach to a from the left of f of x is equal to limits as x approach to a from the right of f of x. That is the limit continuous. Now I'm gonna talk about the next one, or limit exists, sorry. So the next one is gonna be continuous. On the last test, you guys messed up this question, which is I was kind of disappointed. I told you what's on the test, and you guys still mess up. That's the part I was more upset about because I say just memorize this and make an index card, just memorize this. But it's not memorization, just like pure understanding. What's the first condition where f is continuous? What's the first condition? No, that's not the first condition. What is the first condition, Peter? F of a is defined. F of a is defined, and it's gonna be a solid dot here. That's the first thing. I'm gonna different color code this. The second one, what is the second one? What's the second condition, Amara? No. Limit x approach to a of f of x exists, which is the bottom part here. Limit exists, right? So limit exists. Does that mean it's a continuous? Is this continuous at this moment right now? In terms of graphing on the right hand side, is that limit? Is that continuous? Are you sure? It's not. If you have 2 conditions, it's not really continuous yet, right? It requires 3 conditions. What is the third condition? What did Amira say? Well, it's actually the limit x approach to a of f of x must equal to f of a. So first one must equal the second one. So those 2 is this. So that makes this graph here that is like go and move up to here and then say, oh, okay, now it's continuous because I fill in the circle, and that's this. Now, also at the same time, right, think about this roller coaster, right? Would you want to ride a roller coaster where you have a hole here? No, because, yes, okay. Why are you more courageous than other people? So, but yeah, normally you won't want to ride it, or at least wait until after the test. No, don't do self-harm. Um, so you don't want to ride this with a hole, right? But this one, if you ride a roller coaster here, it's it's gonna be kind of crazy still because your thing's gonna be fly out of track, and that's not the ideal. So I will say, according to analogy, so I'm gonna write analogy in not real situation. So think about this roller coaster. So the roller coaster, this analogy wise, this is a connected, and this one's a roller coaster. This is actually broken roller coaster. This is actually broken roller coaster. But this one, the second one, at least is connected. But ideal is connected doesn't mean it's a good roller coaster because you're still gonna probably die if you fly out of track. So then you need something called differentiable. Differentiable is our highest goal. Differentiable means the slope from left equal to slope from right. Okay, so how do I do that notation inside here? The notation is going to be limits as x approached a from the left of f of x, prime of x, not f of x, right? It's different than first layer. This means slope from the left equal to limit x approach to right of f prime of x. So slope from the left had to equal to slope from the right. If that's true, then it's differentiable. So what do they look like? They look like something like this, right? This is always completely smooth. If you ride on this roller coaster, it's all connected to the track. Like think about the slope on the right is gonna be the red line here, but the slope from the other side is gonna be like this. So they are like continuous. The slope is continuous. It's not gonna be get out of track because there's no drastic change of slope. If you have drastic change of slope from 1 to even 2, let's just say if you have a slope like this, it's connected this way. Like slope is 1 here and slope is 2 is right here. You don't want to ride a roller coaster here because when you ride it like here, it hit this part, you're going to broke the track. So it's minus was it's not riding those roller coaster. Does that make sense? If you have a slope change, a drastic change. Even change from 1 to 2 is a drastic change. Yes, Ethan. Slight change depend on how much a slight change, because normally you have a very minimum changes, like slope it will changing from 0.01 to 0.02. That's a slow change that I will call it smooth. Longest smooth is fine, but if like to be very detailed is the slope has to be so minuscule changes in order to be completely smooth, right? Because you look at a microscopic point that on a track from the left on the right, it should be very similar to each other. They're not going to be the same because it's not a horizontal line, or it's not if it's a horizontal line, it's always stay the same. No, that's not what we're looking for, because you ride a roller coaster, it's no fun. So when it's not differentiable, okay, so when the function is not differentiable, mhm.
Why doesn't the one like on the top of the prime make it connected?
What'd you say?
Why does the one with the prime make it connected?
This one here is not connected.
Like, why does it make it connected?
That makes connected because it has to have all those conditions first. Because you cannot build the top part of the pyramid. So that's a good question. I'm glad that Leah pointed out. So One thing that I would always tell students on AP exam, they test this this pyramid a lot, is they will tell you, yeah, if the function is continuous, does that mean it's differentiable? Not necessary, because you're on the bottom part of the things. So if you build the pyramid halfway, it's only continuous. Does that mean that the function is differentiable? Not necessary. It could be, but it's necessary. You want to make sure you create completely true statement. So if its function is continuous, does not imply differentiable. Does not. Okay. Maya, are you paying attention? Okay. But if a function is differentiable, what does that imply? It has to be continuous. Limit has to exist because you already have a top part of the pyramid. You have to have a bottom part of the pyramid. If I just say continuous, does limit exist? Yes. But does not mean it's differentiable. But if I say it's differentiable, it must mean continuous and limit exist at the same time. And also, not only that, the subcondition has to be true. If it's a differentiable, it's a function, it's FA defined. Is f of a defined? Yeah, because that's a condition to be continuous. Is limit x approach a exists? Yes. So it must fulfill all the conditions. AP exam love ask this. At least 2 multiple choice questions based on this. 2 multiple choice is a lot. That's almost 2.4 points. And you only need 42 points to get a 5, to get a 3. So by understanding this diagram, it's a big part. Okay? Now, when is function not differentiable? Well, first, function not differentiable, it has to be, well, they are not continuous, of course, because it's not continuous, automatically it's not differentiable. Well, the first way is there's a hole, which is remove discontinuity. The second thing it can possibly is a vertical asymptote. Okay. Second, it's not continuous is when you have a sharp turn. What kind of function has a sharp turn? Can you name one function has sharp turn? Absolute value x. Good job. F of x equal to absolute value x. That's a sharp turn. Why is that sharp turn? Like if you look at absolute value function, it's like this. It has changes slope from -1 to +1, right? Now you also can have a second condition. So this is A. B is could be a f of x is equal to x to the 2/3. Now is x2 even over odd power? Even over odd power is going to create a second situation called a cusp. There's a name for this. It's called a cusp. Cusp also fulfill the third condition, the third situation though. Third situation is called vertical tangent. Vertical tangent is also another one. It's not differentiable. So when you see something in a vertical tangent, that's not differentiable. Now this one doesn't really work with the roller coaster analogy because roller coaster can have vertical tangent. So it doesn't really work with that. So what does a vertical tangent look like? Well, f of x equal to x to the 1/3. This graph is going to look like something like this. And I'm going to show you why they are not differentiable, but it's going to be looking like this. So at this part here, it's not differentiable. Actually, sorry, this graph's not really good. So this graph, so this point here is slope is equal to infinity because it has a straight slope. And straight slope is also known as undefined slope. So when you have vertical tangent, it's automatically not differentiable. So not differentiable. So the like I said, the roller coaster analogy doesn't make sense here. but at least make most of the senses. When you have vertical tangent, it's not differentiable. So there are three situations not differentiable. So what does cusp look like? Well, the cusp look like this. Sorry. The cusp is look like x to the 2/3. Oops, my bad. Even over odd, right? So even over odd, it's like this, 2/3. Do you want to ride a roller coaster look like this? Aria says no, right? And it makes sense because you're gonna die at 0. Not only that, if you pay attention, there's a vertical tangent right here. Right? If you pay attention, this is actually at their slope is gonna be from this side it's gonna reach negative infinity, from the other side it's gonna reach positive infinity. The slope has a drastic change. So it's a cusp. It fits both situations, vertical tangent and at the same time is a sharp turn. Okay. I remember one year I have a guy ask a girl out with this equation, which I thought was kind of cute. Um, so x to the 2/3 is from the top part of the heart. You see the top part of the heart is like this, right? That's a cusp. It has to be x to the 2/3. Now, there's plus of square root r squared plus x squared. Hopefully you guys know what that equation is. Do you guys know what that equation is? Square root x squared, r squared minus x squared. Those of you guys don't know, you need to know for later. It's actually circle, right? So if you have square root of 4 minus x squared, it's going to be a semicircle. Well, it's actually a full circle if you put plus minus, but it's going to be a half circle. So that's the thing. That's why it's restricting both idea and to create these functions like this. So you have x to the 2/3, which is from top part, and the circle is going to make it like a round shapes. So make everything rounded. So it's actually bending one graph to the other graph. It's pretty cool. But with that being said, we know it's not differentiable at those situations. Yes.
What's the vertical tangent of the cusp that you first showed us at x equals 0?
Yeah.
Okay.
So at here. So let me draw a cusp here. Is even over odd power is going to be like something like this. It's also a vertical tangent here too. Yes.
Is the vertical tangent for any exponent that's a fraction, or does it have to be like odd?
Usually it's a fractional exponents. That just say if you have even over odd like this, let's say 4/3, right? 4/3 is like actually look kind of like parabola. I think this one's differentiable. It has to be less than 1. And it's a fraction. So let's say 1/5. 1/5. And we're going to talk about why that is. See that this is a vertical tangent there? Do you see that the vertical tangent 1/5? And the reason why it's like this, if I use the definition derivative, because right now I don't know how to use power rule yet. If I use the definition derivative, it's limits h approach 0, not h approach 0, x approach c of f of x minus f of c over x minus c. This is f prime of c. Do you guys remember this? What does that mean? If I have f of x equal to x to the 1/3, what will happen is actually limit x approach to 0, and f of x is going to be x to the 1/3 minus, if I plug in f of c, f of 0 is equal to 0, so it's 0 over x minus 0. Is that okay? Now can I rewrite that says f prime of 0 here? Yeah, so that's equal to limits as x approach 0 of x to the 1/3 over x. Now that's going to be limit x to the 0, 1 over x to the 2/3. Is that okay? I just simplified. Now, limit x approach 0 at 1 over x to the 2/3. Now, imagine if this part is going to 0, what will happen? If the bottom part is going towards 0, x to the 2/3 going to 0, what will happen to the slope? If a bottom part goes into 0, what will happen to the slope? Yes, Arya? You'll be vertical tangent, but why is it vertical though? If I have plugged in a small value that says 0.1, right? And 1 over 0.1 is going to be 10. So it's the smaller I plug in, the smaller value on the bottom, but the 1's divided by a very small number. So this will eventually go to infinite. So slope is infinite is a vertical tangent. So at that place is a vertical tangent. Now this will work with absolute value as well. So let's just say if you have f of x equal to absolute value of x minus 2, we know this one can be piecewise function. It's going to be x minus 2 when x is greater than 2. And it's going to be x minus 2 when x is less than 2, right? So then what happened at slope at 2? Well, the slope at 2 is limits x approach to 2 from the left, right? From the left, I'm going to use the negative x minus 2 over x minus 2. I use these functions here. Then this will cancel out to get me a negative 1. Now, if I look at from the other side, which is limits x approach 2 from the right, this one's going to be x minus 2 over x minus 2 because I use the positive version of the graph. And this cancels out to 1. So limits us, so f prime of 2, it does not exist. Why? Because from the left side, it's going to be negative right. From the right side, it's going to be positive 1. I use the definition of derivative. I use the definition of alternative derivative. And I find out limit x approach 2 does not exist. I love the questions because this one has some understanding. Yesterday, Alejandra says, hey, I want to take another questions to do. So she do it on a board over there. She picked the x squared minus what? Absolute value x squared minus what? 6 absolute value. And she picked some function from the left, some function on the right. She know on the left side it's going to be negative 12. On the right side it's going to be positive 12. So she said slope at that particular point does not exist. Okay, slope at that point does not exist. C is equal to what over there? Oh, 6 does exist. Hold on a second. X squared minus 6 or x squared minus 36. Huh? 36 is going to be different.
Wait, yesterday, why didn't we add in C?
What?
We don't have like f of x minus c.
F of x minus f of c over x minus c. That's the alternative.
But f of x is x minus 2, so on the top, why didn't we do that?
Is it?
Minus 2.
No, it's minus f of 0, f of 2. F of 2 is going to be 0. Right, so technically there's a minus 0 here. Yes, Ember?
How did you go from the x to the 1 over 3 over x to 1 over x to 2 over 3?
It's a quotient rule for the thing. So 1/3 and the x. This one is going to be x to the 1/3 minus 1. Right. That's x to the negative 2/3, which is 1 over x to 2/3.
Oh, okay. Thank you.
Okay, so yeah. Anyway, those are a few situations does not exist, and there are a reason why. But I'm not gonna spend more time on it because I'd rather spend more time on power rule, which is power rule is very interesting. Did we talk about derivative of a constant yesterday? What's derivative of a constant? 0. Why are they at 0? Is Ariel says a horizontal line, right? So let's say y equal to 2 here. The slope is equal to 0. This is not power rule. This is called constant multiple rule or constant rule. Derivative of any constant. Derivative of e is what? 0 because e is 2.7. Derivative of pi is what? 0. So any number is 0. Derivative of 1,000 also 0. Well, what is the power rule that we talk about so much? The power rule. So remember yesterday we said derivative of x to the n. Basically, you take this n, drop it in the front. So you're going to get nx to the n minus 1. Always. Derivative of x to the x to the n, it has to be nx to the n minus 1. Now, with that one condition, so I'm going to write down that condition, it's very important. This is on numerator. If the denominator doesn't work, if 1 over xn doesn't not work, so 1 over, it doesn't say it's 1 over x to the n. So it has to be x to the n. It has to be on numerator. If it's not on numerator, you need to find a way to get there. So let's show you what's derivative of x squared. What's derivative of x squared? It's just 2x, right? It's 2x to the 2 minus 1, so it'll be 2x. Now imagine that if I would do a definition of derivative. It's going to be a lot of work, right? X equals 0, x plus h squared minus x squared over h. And that's equal to limit h equals 0. So much writing. X squared plus 2hx, which is you have to do that tomorrow. Yeah, you have a quiz tomorrow about definition of derivative. But one nice thing is you can check your answer now because you know the power rule. I mainly check your algebra skill. If your algebra skill does not make sense, then and then h is going to go to 0 after you replace that's 2x. Do you see how much work? And how much work is this? Which way do you do it? Of course you prefer this way. So after tomorrow, you can use this way. But tomorrow's quiz, you're going to have 2 questions. You're going to have to use definition of derivative. Unfortunately, I need to ask you how to do it algebraically.
So the quiz is going to be on like all this.
Alternative derivative, not power rule. But do you see that this is much easier? And this is called power rule.
But can you explain how you got from like how do you get formula to get 2x? Like,
Yeah, because I factor out h and h cancel out.
no, just using the power rule, like using the power rule.
Oh, just yeah. So 2 is gonna drop it in front. So you're gonna have 2x. But the 2 is gonna subtract 1. So it'll be 2x. Because it just take the power, put in the front. And the power is gonna subtract 1. But with the condition that x has to be on numerator. So can you take a derivative of this? Is this x on numerator? Can you do algebra to make it to the numerator? And this is a part of you guys, algebra is weaker. You need to understand, algebra is going to be the fundamental of everything. If you improve your algebra, you can change 2 things, 2 outcomes. One is your SAT outcome. One's your calculus outcome. So you have a choice to knock out 2 birds, 1 stone. And here's 2 birds, 1 stone. You can actually know all the exponent rule. Let's say a to the negative n equal to 1 over a to the n. Or 1 over a to the negative n equal to a n over 1. This is called negative exponent rule, right? We learned that in algebra 1. Can I take a derivative 1 over x squared as of right now? No. What do I have to do? Bring to the top. So it'll be x to which power? Negative 2. Now I can take a derivative. Because I can put this in the front. So it'll be negative 2 x to the negative 2 minus 1. Is that okay? So it'll be negative 2 x to the negative 3. Now I can change to back because after I take a derivative, it's going to be like this. And that's it. I'm done. It's not a lot of work. Yes.
What if, like, so if n was 3, right? Or it was the third power, right? It'd be 3x to square squared.
Mhm.
Oh,
Am I going?
We leave it as -2x to -3 power.
I don't prefer it. I like when you change to the x to the third on the bottom. I just prefer the positive exponent. It's just because what if I want you to plug in 2? You're gonna be 2 to the -3, but a lot of people think about 2 to the -3 is a negative number. It's not. Okay, so is that okay?
Because yeah, okay.
Okay, so now let's take a derivative of this. Now, I want to talk about this one as well. D to the dx of c f of x. C is a constant. The c can be taken outside in the front. So d to the dx of c of f of x, and that's equal to c of f prime of x. That's called a constant multiple rule. So how do I take a derivative of this? 4 root x. Do I have to worry about 4? Can I take it in the front like this? So be 4 d to the dx of root x, which is also known as root x is what? 1/2 power, right? Constant multiple rule, yeah. Can I take a derivative x to the 1/2? So the 4 is still in the front. 1/2 is here. X to the -1/2. Why is -1/2? Because 1/2 minus 1 is a -1/2. So that would 2x to the -1/2, or 2 over x to the 1/2, or 2 over square root x. And that becomes the derivative of 4 root x. Am I going too fast? Yes?
It's negative 1/2.
Oh, I'm sorry. No. Yeah, you're gonna subtract this place in the front, right? It's 1/2, and then 1/2 subtract 1 is -1/2. So 1/2 subtract 1 is -1/2. Is that okay? Now, what would be derivative of this? No, 4, 5. How do I take a derivative of this?
Radical x over never mind.
No.
Change the except x to 1/2.
Mariah, what are you saying?
Can you change the square root to 1/2 and then you combine your x's and then you bring that to the top?
What will be x times x 1/2?
3/2.
Okay, good. So it'll be 5 over x times x to the 1/2, right? This one is going to be d to the dx of 5 over x to the 3/2, right? And that's d to the dx. I haven't taken a derivative yet, if you realize, and it's like this. Am I doing okay? Now I'm going to take a derivative. 5 times -3/2, the constant leave in the front, x to the -5/2. Is that okay? So it'll be -15/2, x to the 5/2 on bottom, or -15/2. It's going to be x squared square root x. I mean, either answer is acceptable. I think this answer I prefer. -5/2. I prefer this answer. Just because I don't really need a simplified radical. Yes.
It says derivative 5 over what?
5 over x to 3/2. Because this is 1 plus 1/2 is 3/2, right? It's just a power rule. 5 over x to 3/2. Is that okay?
No, the one to the left. 3 circle.
5 over x to the 3 over 2. And you change that 5 to the x to the negative 3 over 2. Now there's an easy one. What's the derivative of 4x? What'd you say, Amber? What's the derivative of 4x?
4 d over dx and then the x. Or even 4 in front.
Okay, so what would it be? What's the final answer be?
Wouldn't it be
What?
Would it be 4?
4 is correct. But you don't need to do power rule in this case. Guys, you don't need to do power rule. If you have y equal to 4x, what is slope? This is the m, right? So you don't need to do that. Derivative of 4x is just 4, just a number in front of x, the x to the first power, because it's linear. Now, if you want to take a derivative of 4x to the 1, that 1 is going to be here, x to the 0. What's x to the 0? 1. So 4 times 1 times 1. Its derivative of 4x is just equal to 4. Yeah.
You know how you have like the equals, is it negative 15 equals 2x squared?
2x squared over x, yeah. Okay, so what's the derivative of following things? I kind of ran out of time here again, so you guys have to watch the end of the video, unfortunately. So, if I take a derivative of following things, let's just say this is the following thing. The following thing says, hey, I want to take a derivative of those things. 5 over 2x to the cube. And y equal to 5 over 2x to the cube. It looks very similar. Y equal to 7 over 3x to the negative 2. And y equals 7 over 3x to the negative 2. So if I want to take a derivative of all those 4 functions here, start with the first one. How do I rewrite this? Well, 5 over 2, x to which power? Negative 3, right? You probably have to finish watching this part, so it'll be 5 over 2 times negative 3 x to the negative 4, so it'll be negative 15 over 2 x to the 4th. So for here, it's going to be, I rewrite them, it's going to be ax to the 3. Now that's equal to 5 over 8x to the 3 here. Now that's going to give you y prime is equal to 15 over 8 x to the square. Again, this one just algebra, so 7 over 3 x to the 2, and that's going to be 14 over 3x.
For the ax one, how can you bring the x cubed back down? Because if it's on the denominator, you're doing x cubed, wouldn't that?
Oh, this one's next to negative 3, sorry. So this is negative 5, it is a negative 4.
Negative 4.
Here it's going to be 7 over 3 to the negative 2. X to the negative 2. That means y equal to 7 times 3 squared times x to the 2. Now make sure you watch your last 3 minutes of videos. So y prime is equal to 126x. There's another 2 example after that. They are pretty easy.
I'm coming on table, but I just need to.
You don't need a what?
I'm coming. I just have